The last class wasn't recorded. Because of that, I'm going to start this class from the scratch. And we're going to get it somewhere, actually. Yeah. So talking about set. Set is simply a collection of one or two or more elements. A mathematical set consists of stuffs. So those stuffs there are the elements. And if this is A, it's written in capital letter. Why? Because it is a set. It is equal to A, B, C, D. All these ones are written in small letters. Why? Because they are elements. So I can say now that A is an element of A. B is an element of set A. C is an element of set A. And D is an element of set A. Also, I can look at this set A and look at the number of sets inside it. This is the notation. This is how we denote it. Using this is an element of, so this E, or A is an element of A, B is an element of A. It's the same thing. C is an element of A, D is an element of A, in case you meet either of them. So now the number of elements in A is 1, 2, 3, 4. I have 4 elements in A. I have 4 elements in A. That means the number of elements is known as the cardinal number. The cardinal number of set A, that is n of A, is equal to what? 4. N of A is equal to 4. Sorry. Yeah. So now I can consider another set now. Let me call that set B. And set B is equal to C, D, E, F, G. What I observe from set B is that G is an element of set B. C is an element of set B. D is an element of set B. E is an element of set B. All these are elements of set B. So now the number of elements in set B is equal to 1, 2, 3, 4, 5. 5. Now this is where I'm going to be looking at relationship between one or two sets. This is a set A and this is a set B. What is the relationship? There is an element in set B, which is C. That C is in set A as well. D is in set A, D is in set B as well. So that means the two of them have something in common. Because they have something in common, that thing joins them together. So I can say they are joint sets. Joint sets. And even they have nothing in common, then I'll call them disjoint sets. Like a set P, which is 1, 2, 3. And another set Q, which is 4, 5, 6. What is common between these two sets? Nothing. So the two sets are known as disjoint sets. Now these ones we have A and B. They are joint sets. Why? Because they have C and D in common. So how do I denote C and D that is common to the both of them? Then I'll say C and D intersect between set A and set B. Therefore, set A intersection set B is equal to what element? C and D. That is the element that is present in A and at the same time present in B. So I call this A cap B because it looks like a cap. What you wear downward, it looks like a cap. A cap B. Now I can also find way. So this is A intersection B. I can also find way to write these two sets together, and that will be the union of set A and set B. That means the two sets are together. That is A union B. And that is equal to write all the sets together. A, B, C, D. I've written set A. Now let us write B. No repetition in set. So So I won't write C and D again. So jump. E, F, G. This is A union B. That means all the elements in A and all the elements in B reaching together. So we call this A, I call this basically A cup B. And I call this A cap B. So A cup B is A union B. Union means the both of them come together. Intersection means what is present in the both of them, present in the first and at the same time present in the second. So the cardinal number of sets N intersection B, that is number of A intersection B rather, is 1 and 2. And the number of A union B is equal to 1, 2, 3, 4, 5, 6, 7. Now there is a type of set. This is a set Q that is having the curly bracket. The curly bracket is there, but no element is in there. That means the number of elements in set Q is 0. A type of set that does not have element at all is known as a null set or an empty set because it doesn't have any element in it. It can also be written as set Q is equal to, this is it. Look at what I wrote here, 5. So this, it is not Q that I wrote. Whenever you see something like this, know that the set does not contain any element. It is null set. It is an empty set. That is what I mean by that. Now, this is a set A. It is equal to 1, 2, 3. This is a set B. It is equal to 4, 5, 6. And this is a set C. It is equal to 7, 8, 9. What is A intersection B intersection C? That means what is inside set A, inside set B, and is inside set C at the same time. What is that? Nothing. So I write this. A union B union C means what is inside the three of them together. That is going to be 1, 2, 3. B is what? 4, 5, 6, right? 4, 5, 6. C is what? 7, 8, 9. So if I say this is a set consists of all numbers, all natural numbers. That means the set can be N is equal to all natural numbers. Start counting. 1, 2, 3, 4, 5. I can't finish counting the natural numbers. So I'll just use 3 dots. The 3 dots means infinity. To infinity. So this is a set of natural numbers. Also, there is a set of whole numbers. Whole numbers is written as NO, N naught or W. And that is natural numbers also, but it includes 0. Whole numbers have 0, 0, 1, 2, 3, 4, 5, to infinity. Integers can be positive or negative. So we have them like that. But there are 3 ways we can represent a set. One is the normal method you are seeing here. That is the grouped or tabular method. Another one is the description method. Description method means writing this set in this form. N is natural numbers. N is a set of natural numbers. What did I just do? I just described the set. And this is a set. Yes, I just described the set. I wrote it in the description form. You are the one that will come and form it by yourself. Set of natural numbers. That means you should start writing from 1 to infinity. If they said W is a set of whole numbers, you should form it in your tabular form from 0 to infinity. If it is a set of these, so the 3 methods for representing a set are the grouped or tabular method, the set builder method, and the description method. These are the 3 methods. It might be an OBJ question that we use to represent sets. The 3 methods we write sets. And after that now, there can be a set which is a very big set, an ultimate set, which all other sets are being related to. Other sets are making reference to it. So I can call this set the set of alphabet. Let me represent it with omega, capital letter omega. Set of English alphabet. That is from A, B, C up to what? Y, Z. Now I can say this is a set A. Set A is equal to A, B, C, D. I can say this is a set B. Set B is equal to E, F, G, H. Now, all the elements that I have in A are also present in omega. That means set A is a smaller form of set omega. So I will say A is a subset of omega. Also, B is also a smaller form, smaller form of omega. That means B is a smaller form of omega. As these things are smaller forms of omega, then I can say omega is a bigger form of them. So omega is a super form of these things. So omega is a super form of A, omega is a super form of B. So the notation means A is a subset. The reason I'm rushing is that I've explained this thing before. It was a pity we didn't record the class. So I suppose you should know one or two things about it now. That's why I'm not taking it very slowly rather. So A is a subset of omega, and omega is a superset. Superset like greater than, subset like less than. That is what it means. Now, if this is the complement, this is the C. This is the universal set. I'm using epsilon. I'm using U to represent it. Curly U. We call this the curly U. Is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a set. Now, if this is another set P, and set P is 1, 2, 3. If this is the universal set, we call it the universal set. The set which other sets are being related to, we call it the what? The universal set. So I can say P is a subset of the universal set, right? So any element that is not in P, but is still in the universal set, is known as P complement. Is known as what? P complement. So it is written this way, P complement. That means the elements that are in the universal set but not in P. I'm sure you will encounter questions like this. In the universal set but not in P. And what are those elements? 4, 5, 6, 7, 8, 9. So this is P complement. So if this is my set Q, which is equal to 8, 9, 4, 7, then Q complement is going to be what? 1, 2, 3, 4, 5, 6. Right? Okay, 4 will not be there. That means the elements that are in the universal set but not in Q. That is what we mean by Q complement. Now, with this, you can know the number of P complements. With this, you can know the number of Q complements. So, that is a quick introduction to everything about set. In the next class, we'll be talking about Cartesian product of sets. Cartesian product of sets, which you are going to be encountering questions on. It's not hard at all. And if you're able to, I think I'm going to make a video to explain that, or perhaps a class like this that I'll just talk to Kingsmith to create time for me, and we make the recording and drop it. For now, I'm going to get with something else. But tomorrow, there'll be a class for Maths 211. So please watch this recording. And I'm sure we've had the class before. May God help us all. Thank you.